Hello everyone, welcome to Learn Overflow. In this video, we'll discuss another LeetCode problem. There is a concatenation of consecutive binary numbers. So this is a medium level problem, and we'll understand how this question goes on and how we can solve this much faster. Okay. So before moving on, if you haven't subscribed to the channel, make sure to subscribe to Learn Overflow for regular LeetCode videos like this. The question says we are given an integer n. So this integer n given to us, and then we have to return a decimal value of the binary string formed by concatenating the binary representation of 1 to n. Okay, so we need to return the decimal value of the binary string formed by concatenating the binary representation of 1 to n. So 1 to n, fine. In order, okay, in order, modulo 10 to the power 9 plus 7. Okay, so that's okay. So what it exactly means, okay? So if we got n equals to 3, fine. Say we got n equals 3, then what it means? The first thing is n equal to 1. Its binary representation is 1, fine. And what is a concatenated string? Initially it's 1, fine. Next is 2. We find it binary representation is 1 0, fine. And so for this binary representation, our concatenated string will be this 1, the previous one remains as it is, and then we add 1 0 to it, fine. The next is 3. For this 3, our binary representation is 1 1, and the concatenated string is formed as this equally like 1 1 0, whoever is there previously, and then followed by this 1 1. So this is the concatenated string that's formed at last, and if we convert this binary form to decimal, then it forms something like 27. If you're not sure, then just count it. 2 to the power 0 is 1, 2 to the power 2 is 2, like 2 to the power 1 is 2, then 2 to the power 3 into 0, then 2 to the power 4 is 8, fine, and then 2 to the power 5 is 16, right? So this is the values we got. Then 8 plus 2 10, 16 plus 1 17, 17 plus 10 is 27. See the calculation, if we just convert this to binary, the calculation becomes 27. Yes, and the final answer is 27. Look at example number 22. So the final answer, if we have 3, the final answer becomes 27. So that's how it is going on. Like that's exactly the question formation is. So what we can do to like form this question? The first thing is, when we need to convert this to binary and do our binary calculations and all, so we won't be to going ahead with like there's no point doing anything else to find out rather than doing a bitwise operation. Okay, like you need to do bitwise. Is it eventually will result in the faster. And now the question is, we might argue that why we are not doing integer dot binary string directly converting to string. Those can be done, but obviously, when you need to operate with bit, it's preferable to go with bitwise. That gives you like a faster. And obviously, why don't you want to go with a bitwise? It is the kind of a good method, right? So, what exactly we are doing? See, from 1 till n, right? From 1 till n, we are going the n value being as 3. Now, for each value, we are converting it to binary. Okay. So how we are actually converting it to binary? If you directly give some kind of like binary operation to it, like binary, I mean, say a single or a single and, not the double and. Double and would result in like not a bitwise operation. If you do a single and or a single or, this kind of operations would usually result in binary operations. Okay, like this works in binary. So how this actually works? So whatever the first thing is, whatever the binary we get, okay, we'll convert it to binary somewhere. But this is what is the binary we get? We need to move this digit. How many bits to the left? Like when you're moving bits to the left, that means left shift is coming into place. Okay, because we are in binary, so we are moving it to the number of bits we have in this. Fine. So the number of bits we have in this, we are moving that number of bits to the left and then adding it to the like how we are adding it. Say we have 1, okay, 1. Then we are doing a left shift 2 plus, right? Because it's when we are at 2, then the 2 got a length of 2 as its a binary number. Okay, so we are doing a left shift 2 plus, so that becomes 1 and then 0 0. Fine. Actually, you know what? When you're doing left shift 2 plus, this is actually like 2 into like 2 to the power. If you just look whatever value is there, that's the value 2 to the power 2. So that's if you just look 100 is actually 4. Okay, so just an additional information this one question, nothing necessary at this point. Now let's see, we got we left shift 1 2 places, so that's 100. Okay, and we got over here 10, that is our current binary. So how will we add this, like how will we put this together? This is simple operation like a or operation. Do a or operation between these two. What will happen? See, if the initial bit is 0, so 0 or 1, 1, and 0 1 1, and then 0 and 0 0, like 0 or 0 0. So this is how the or operation works, and this is how you can actually store it, because you have just left shifted. There's no additional subtraction going on, right? So whichever positions this have values, those positions will eventually be 0. So or operation will result in this particular value you can get. So that's what we are doing. And then again, we got two places as our length. Okay, so once you got two places as well, then we will left shift this particular value two places. So once if we left shift this two places, that means we'll eventually add two zeros at the end. Fine. Once left shift is done, now we'll do a or with one, like 0 0 0 1 1. So this is a like a or we'll do, and then eventually this answer will be here. Fine. So that's how we are doing. Now, another question is might come to a mind, like how we should do this, how we should find how many places to shift. Okay. Now, if you have done your string formation, if you have done your binary by string formation, like integer dot to, integer dot two binary string is there probably. So if you're doing it by that method, no, integer the two binary string, yes, that's there. So if you're doing binary conversion by that method, so directly take the length, you can do that. But let's do it bitwise, okay? You know, when is the time when, like, what is the exact time when our length of this binary increases? So length of this binary increases at every power of 2, fine? So if you look, this was 1, it has a length like 1. Okay, so previously, if we look, 0 has a length 0, fine, and then we got 1, so that means 2 to the power 0 is 1, then 2 to the power 1 is 1 0. See, the length got increased. Then if you look at 4, sorry, if you look at 4, then you will see this is 1 0 0. So 2 to the power 3 is 4, and you find the length got increased. Similarly, if you look at 8, fine, you will see this, that is 1 0 0 0. Fine. Again, the length is increasing. Then if you look at 16, you will see similarly the length will increase. Fine. So we can have a small variable with us. Fine. We can have a small variable with us that will store initial length. Fine. And then whenever we find something as a power of 2, that like our m being of current n being of power of 2, we need to increase our length and increase the left shift according. Fine. So that's the operation. Now, when you're directly doing an or operation like this, you are directly converting it to binary. So if you're just still confusing what's going on over here, give me a moment. Let me quickly write down the code. You will understand exactly what is going on. But also, if you're not sure how to find the power of 2, so there's an exact video on this, how to calculate the power of 2. It's simply I and like I and I minus 1. So if you do an or like AND operation of I and I minus 1, and if this resultant is 0, then it's a power of 2. So I have explained it how it goes like this. So it's there, a separate video is there on this channel. You can find that out. Okay. So let me quickly write this code, and you will understand what exactly is going on over here. Like directly left shifting and then or doing an or operation of that current value. That will result in the binary being added to it. Okay, so let's quickly go ahead and write it. So there is this question, and as you know, this LeetCode judge is always confusing with what the time complexity is. Okay. So first of all, the exact time complexity for this answer is order of n, because we're just referencing order of n. Right. Now let's understand this. So first we got this sum, long sum, that will store our final results. This is like 0 initially, and then this is our length. So length being the value, as I say, this is stored how much left shift is needed for us. Fine. Now see, we are traversing each of the numbers. Now I and I minus 1, as I said, this looks for power of 2. Once we find a power of 2, it will return us we'll increment the length. That means the number of bits we need to left shift should be more over here. Okay, whenever we find this. So if I just give you an example, say we got a value like 2. So 2 is 1, 0, 5, and I minus 1 is 1. So that means 0, 1, 5. So that's value. And we do an AND operation between them. So 0 and 1, like 1 and 0 results in 1 and 0 results in 0, fine. So and then 0 and 1 results in 0, but that's the value we see. So when 0, 0 is actually what 0. So whenever you will find and number like that, like 2 to the power of value, you will see the number will be like I and I minus 1 will result in like this, will result in 0. Just another example, say we got 100, that means 4. And what is the value of 3? That is 1, 1. Because every time you will see the two like power of 2 will be something in this format, 1 then followed by zeros. Okay. If you do an AND operation between this will again result in 0, 0, 0. So that's the way. So whenever we find an power of 2, we'll simply implement our length. Okay. In the else case, like normally what we do, whatever our current sum is, we'll left shift the sum by this length and do our OR operation with our current time. So this OR operation with our current time directly results in converting it to a binary format. Okay, so that's what we are doing, and then we are doing this modulo operation just to make sure it's not going out of our length. So if you're not sure why this modulo operation is useful, I can give you an example in this case. See, if in the example 3, whenever the n is 12, the resultant binary becomes something like this. Fine. And if you convert to decimal, the decimal value looks something like this. This is not an integer value. So after we do 10 to the power 9 plus 7, what we are doing, we are just taking the last bits. Look exactly. So this more or less is a value. Okay. If you just look carefully, this is more or less the value that will end up will get, because like that's the more or less the value we want actually. Okay. See. You can argue that the last few digits are not there, but whenever it's a very large value, that's the kind of approximation we are doing. Considering. Okay, so that's how this mod operation works. Fine. That's not the question. So what exactly we're doing? We simply did a left shift of our length, like 1 hour length, and then did a OR operation with our OR operation with our current of the current value or the current I we got. Okay, so that's the step we're doing. So this is pretty much fast solution. As you know, this list course is pretty confusing with what they're trying to do. Anyways, it doesn't matter. So this is the more or less the solution we are looking for, and that's how we are finding us. Look, this all of a sudden went down to 81 ms. Actually, it should actually go down to 80 ms, and that's is 100% faster as well. So that this doesn't matter. Fine. So I hope it's the explanation understandable. So thank you all for watching this video. Make sure to comment down if you have any doubts or any confusion still remaining. I'll be happy to help you out in that. And also like this video and share it with your friends who are doing this problem or finding it difficult in this problem. Fine. So thank you for watching this video. Hope to see you soon in my next video as well. Thank you.